In this video, we're going to be looking at how we would forecast if our time series pattern exhibits that we're dealing with a seasonal pattern. Again, for the purpose of the 2.6 videos, I will not be looking at how to establish what the pattern is. If you need help on establishing the pattern, please consult the 2.3 videos. After establishing our time series plots, we should be able to see that the pattern appears to be relatively horizontal. However, we do have a seasonal pattern. We have a separation in certain quarters have better sales than other quarters. So we would simply say for part A that there appears to be a seasonal pattern. And now that there's a seasonal pattern, we've got a little more work to do with our forecasting method. So unlike when we simply had an upward or a downward linear trend and all we needed to base our predictive model on was sales going up period after period, or with a downward trend going down period after period, here we need to establish a forecasting method which will take into account that quarter one sales are different from quarter two sales, are different from quarter three, different from quarter four. So we can't do simple regression simply based on the period of time. Here we want to deal with a multiple regression forecasting model where each of our different seasons have a prediction based on sales in the coming periods being specific to that season. Now, the way we do this is we first establish a series of something called dummy variables. And as we establish these dummy variables, what we will need is always one less dummy variable than we have seasons. So in this case, because our seasons are quarterly, 4 quarters, we will need 3 dummy variables. And as we get our predictive method, I'll explain why we only need the 3. So based on our original data where we have everything in order by period, we're going to insert an extra 3 columns, again, because our seasons are quarterly, 4 seasons. We need 1 less than there are seasons. So I'm going to simply enter 3 new columns into this, labeling my columns Q1, Q2, and Q3. So how I want these dummy variables to work is the only possible numbers that will appear in any of these columns are either a 1 or a 0. If my period happens to be a first quarter or Q1, I want the variable in that column to represent that it's a first quarter. If it's not a first quarter, then I want the variable in this row to represent that it's not, or the number 0. So to do this, we're going to simply use an Excel function that is going to look as to whether this row and column deals with the fact that we're dealing with a first quarter. So an if function equals if this is a first quarter. So looking here, what quarter are we in? If we're in quarter 1, then I want a 1 in there. If we're not dealing with quarter 1, then we want a 0. Similarly, I'm going to do the same thing with quarters 2 and 3. So equals if this is a quarter 2 now. So if that column that represents quarters is telling me that it's quarter 2, again, I want that value to be a 1. If it's anything other than quarter 2, I want it to be a 0. And then we'll do it one last time for quarter 3. So if this cell is quarter 3 now, or equals 3, then we want a 1, otherwise a 0. And the reason we do that with if functions, it's a lot more efficient and a lot less chance of error for us using Excel functions as opposed to manually inputting all those values. So we notice every time we have a quarter 1, Q1 should be 1, everything else should be 0. Similarly, quarter 2 is 1, everything else is 0. Same with quarter 3. And notice if we're dealing with quarter 4, then everything is 0. So once we have our dummy variables established, now we're going to create our multiple regression equation that will help us do our forecasting for the following periods. Let me get this stuff out of the way. And in this case, we want to make predictions for year 6 for quarters 1, 2, 3, and 4. So in order to do that, as we said, the first thing we need is our multiple regression equation. So again, going to data analysis, regression. So our dependent variable, again, what we're trying to predict, are sales. And now, in order to predict our sales, it is not merely the simple regression based on which period we're in, because now we have different sales depending on which season we're dealing with, in this case, which quarter we're dealing with. We want our independent variables to be those dummy variables that we created. The dummy variables dealing with each of the quarters. And remember, one less dummy variable than we have seasons. So our 3 dummy variables in this case, Q1, Q2, and Q3. So again, I'm going to choose an appropriate output range here. From our regression output, we should be able to establish our regression equation that will help us make our forecast. So here we have the regression equation. Y hat is equal to 95 plus 29x1 plus 57x2 plus 26x3. So in order to make our forecast now, so remember we're trying to forecast for all the quarters of year 6. Our forecast is based on our regression equation. And again, anything from the regression output will be used over and over. So we want those cells absolute reference. So I'm going to absolute reference my cell with 95 plus the cell with 29, absolute referenced. And remember what that coefficient refers to. That coefficient, again, a nice benefit of doing the labels, that coefficient refers to the variable that is in my Q1 column. So the variable in the Q1 column dealing with the current period that we're looking at, out of this chart, we do not want to absolute reference anything because as I go to predict the next period, I want it to be based on the value that's in the second quarter of year 6. So I would like that to move as I copy and paste my forecasting model down. But now plus 57, absolute reference, times the variable in the Q2 column for this period, plus 26, absolute reference, times the variable in the Q3 column. Hit enter. So for the first quarter of year 6, we get a prediction that this store is going to sell 124 umbrellas. And because everything was referenced back to cells, either absolute referenced or not absolute reference, we should be able to copy and paste this formula down and get our prediction for each of the following quarters of year 6. So here, our 4 predictions for the quarters of year 6 are 124 umbrellas for quarter 1, 152 umbrellas for quarter 2, 121 for quarter 3, and 95 umbrellas for quarter 4. So looking at the reason why we always need one less dummy variable than we have seasons, so remember the coefficient of the first variable is all that will be taken into account as we make our prediction for quarter 1. So it'll sub in 0 values for our second and our third independent variables. Similarly for quarter 2 or season 2, it will sub in 0 values for each of the other periods. And as we get down to that last independent variable, that first coefficient will always be the predictive model for that last seasonal period, where it subs in 0 values for each of the other independent variables or each of the other seasons, and simply leaves us with the prediction for our final season. So when we have quarters, we have 3 dummy variables. If we were dealing with breaking things down into monthly seasons, then we would need 11 dummy variables. And that last coefficient would be the prediction for our final month, typically the sales for December.